Hey guys, welcome back to MindSnap. Okay, so if you're watching this, you need to know something right now. A nearly complete blood moon is happening tonight. Not tomorrow, not next week, tonight. And if you live anywhere in North America, you're going to have a ringside seat to one of the most spectacular cosmic events of the year. A lunar eclipse is happening tonight, and you only get this one shot to see it and to photograph it properly. In this video, I'll show you exactly how to see it and how to photograph it, and how to avoid coming home with a blurry gray blob on your screen, even if all you have is a smartphone on a tiny tripod. By the end of this, you'll know when and where to look from your exact location, what time the key phases happen for you, and how high the moon will be in your sky so you can find a clear horizon. You'll know what gear you actually need, from a basic phone to a telephoto lens or a telescope. And I'll give you the exact camera settings I use for each phase of the eclipse so you're not guessing ISO and shutter speed in the dark. And yes, I'm also giving away a Dwarf Mini Smart Telescope in this video. This little thing is a portable, app-controlled telescope that can track the moon for you and automatically capture stacked images, which is really neat. You set it down, connect your phone, tap the moon, and it just follows along while you enjoy the view. I'll explain exactly how to enter for a chance to win it a bit later on, so you have to make sure you stay tuned for that. Now, here's the important part. This guide works no matter where you live on Earth, as long as the eclipse is actually above your horizon. If you're in the north with the moon low in the southeast, or in the south with the moon arcing through the northeast, the process is the same. It's designed for complete beginners who just want a recognizable moon photo and for seasoned astrophotographers who want a refined checklist and reliable settings. A lot of people overcomplicate eclipse photography. They think you need a giant observatory dome and a PhD, which is really interesting because the moon absolutely does not care. You can be in a bright city, you can be out in the countryside, you can even be upside down in Australia with the moon looking the wrong way up. The steps to get a sharp, detailed image are the same. Weather permitting, you can do this with a phone, a DSLR or mirrorless body, or a smart telescope. To keep this organized and fast for you, here's how we'll go. First, I'll explain what makes tonight's eclipse special and what it will actually look like, so you know what you're trying to capture. Then we'll check if it's visible from your location and what time you need to be outside. After that, we'll walk through gear, camera settings phase by phase, focusing, composition, and even backup plans if clouds roll in at the worst possible time. So if that sounds useful, let's dive in and get you ready before the moon enters Earth's shadow. Now, before we talk about how to photograph it, you and I need to be really clear on what you're actually going to see in the sky tonight. This is not a perfectly total eclipse, but it is so close that visually it's going to feel dramatic and a little weird in the best possible way. Technically, we're looking at about 96.2% coverage, which is about as close as you can get before hitting full totality. That means almost the entire moon will slide deep into Earth's umbra, the dark inner shadow, but a tiny bright crescent will survive on one edge. So instead of the whole disk turning evenly dim and red, you get this intense contrast. One razor-sharp white sliver next to a huge, dark, coppery red portion. For photography, that contrast is gold. If you've seen a classic total blood moon, you know the vibe. At full totality, the entire disk is this soft, rusty orange or deep red, evenly dim, almost like someone turned the moon into a lantern. Beautiful, but uniform. Tonight is different. You'll have that same blood moon look over most of the surface, but with a bright sunlit arc still hanging on. It is not a perfect postcard eclipse, but it's a much more dynamic scene, which is really interesting for close-ups and time-lapses. Visually, Here's how the night will unfold, weather permitting. You start with a normal full or nearly full moon. Then you'll notice a bite missing from one side as the partial phase begins. That bite grows and grows, like Pac-Man is slowly eating the moon, until only a thin, bright sliver remains. The rest of the disk will be this dim red or brown glow, sometimes more gray, depending on how dusty and hazy Earth's atmosphere is. And this is where your camera settings cannot stay the same. At the start, the bright moon needs a fast shutter speed and low ISO. As more of it enters shadow, it can be up to thousands of times dimmer, so you have to make sure you lengthen the exposure and adjust as the light falls off. By maximum eclipse, that little surviving crescent will still be blindingly bright, while the red part is very faint, which is really neat, but also tricky to expose. I'll walk you through how to handle that in a bit. Another thing that makes tonight special is how many people can see it. Up to billions of people fall inside the visibility zone, spread across huge swaths of the globe. Most of them will never look up, but you will, and you'll know exactly when to step outside, where along your horizon to search, and what phase you're catching. And here's a fun science teaser before we move on. Everyone in the eclipse zone sees the same phase of the eclipse at the same moment, even though their clocks say different times and the moon might look upside down in the south compared to the north. How does that work? In the next section I'll show you, and it quietly wrecks flat Earth arguments in a very satisfying way. So let's actually unpack that, because this is where the eclipse turns into a little Earth is a globe masterclass. A lunar eclipse is just beautiful geometry in the sky. You've got the sun on one side, the Earth in the middle, and the moon on the other side. When they line up just right, the Earth casts its shadow across the moon, and that's what you're going to see tonight. Now, the nice thing is that this is completely safe to watch with your eyes and with any camera. No filters, no special glasses, nothing. You can stare at the eclipsed moon as long as you like and your eyes will be fine, which is really interesting when you compare it to a solar eclipse. For a solar eclipse, the moon is the one doing the blocking, sliding in front of the sun, and throwing a tiny, fast-moving shadow onto the Earth. Here's the key difference. During a solar eclipse, only people in that narrow shadow path see totality, and as the moon's shadow races across the surface, different cities see different phases at different local times. It might be 10:15 in one town and 10:19 in the next as the shadow sweeps by. But during a lunar eclipse, the roles are flipped. The Earth's big round shadow is out there in space, and the moon is moving through it, so everyone on the night side of Earth sees the same phase at roughly the same moment. Let me make that concrete. Imagine the partial eclipse is at its maximum. Someone in London might be looking up at the sky around midnight. People on the US East Coast are seeing the same chunk taken out of the moon at about 7 or 8 p.m. Their clocks disagree, but the moon's face is identical. At the same instant, someone in India could be catching it before dawn, low over the western horizon, and a viewer in Japan might see it even closer to moonset. Different countries, different languages, same shadow creeping across the same moon in sync. Pattern interrupt for you. Tilt your head 90 degrees. The moon didn't change, but your brain did. In the southern hemisphere, the eclipse can look upside down compared to what people see in the north, which is really neat. Yet the dark bite you see is always curved the same way. That consistently curved edge, no matter where you stand on Earth, is one of the oldest pieces of evidence that we live on a globe. A flat Earth would have to do some very creative yoga to cast the same round shadow from every angle. Now, why does this matter for you tonight? Because that same predictable geometry is exactly why tools like eclipse maps and altitude charts work so well, If you have a clear horizon, we can say in advance how high the moon will be, which side the shadow will enter from, and how deep it will go. In the next part, I'll walk you through how to check all of that for your exact backyard, weather permitting, so you can plan your view and your photos like a pro. Now, let's actually find out if this eclipse is visible from your backyard, your balcony, or out a tiny north-facing bathroom window. I want you to know exactly when to look, where in the sky the moon will be, and whether that tree or skyscraper is going to ruin the view before you even step outside. The easiest way to do that is with a site called timeanddate.com. It's free, it runs in your browser, and it works great on both your phone and your desktop, which is really neat. You don't need an account, you don't need an app, and I'll include the link in the description so you don't have to hunt for it. I'm going to walk you through exactly what to tap so you don't get lost in the interface. So go ahead and open a tab. In the search bar, type Time and Date Lunar Eclipse and tap the result for tonight's eclipse. You should see a page with a big title, some global information, and somewhere on that page there's a button or tab that says Map or Eclipse Map. That's what you want. Click into the map view and you'll see the Earth with colored regions showing where the eclipse is visible. Now zoom in on your part of the world. Pinch to zoom on your phone, scroll on your computer. Find your country, then your state or region, then roughly where you live. It doesn't have to be perfect. Being within a few kilometers is totally fine. Then click or tap on your approximate location. That will pop up a little window and a detailed table just for that spot, which is really interesting because it's doing all the geometry for you. The table will list the start time, maximum eclipse, and end time. Start time is when the Earth's dark shadow first becomes really noticeable on the moon. Maximum is when the coverage peaks at around 96.2%, almost total. End time is when the last bite of shadow slides off and the moon looks full again. All of those times are in your local time zone, so you have to make sure you're reading the right line. You'll also see altitude and azimuth. Altitude is simply how high the moon is above the horizon in degrees. 0 degrees is right on the horizon, 90 degrees is straight overhead. Azimuth is the direction. Around 90 degrees is east, 180 is south, 270 is west, and so on. The site will usually translate that into words like southeast or southwest, so you can just turn your body instead of doing trigonometry. Pause the video for a second and check your own location. If you're in a big city apartment with a wall of buildings to the south, look at the altitude and direction at maximum eclipse and ask, will I actually see the moon there? Or is it behind that tower? If you're in a rural backyard with a gorgeous view but a mountain range to the east, you might find the moon is only 10 degrees up at the start, hiding behind the ridge, but nice and high by maximum. This is where planning really pays off. If your map says the moon is low in the southeast, maybe you walk a block to get a clearer horizon. If it's high in the north or northwest, for you in the southern hemisphere, you might be totally fine on your porch. Either way, weather permitting, you now know if the eclipse is visible at your location, when each phase happens, and where in the sky to look. In the next part, I'm going to take this a step further. Now that you have your times and directions, I'll break down region-specific tips for the northern and southern hemispheres, and then we'll dive straight into the exact camera gear and settings you'll want ready before that first bite appears on the moon. Now, let's zoom in on the northern hemisphere, because this is where things get a little tricky and also really fun. If you're watching from anywhere north of the equator, the big pattern tonight is the moon is going to be low. Not just above the trees, low, but in some places skimming the neighbor's rooftop low, which is really interesting for photos and really annoying if you don't plan ahead. So you have to make sure you understand whether the eclipse starts with the moon already up, or if the moon is still below your local horizon when the first bite happens. That's where that altitude line on time and date comes in. I'll include the link, but here's how to think about it. If that number is under about 15 degrees at your location, you want a super clear horizon. No tall buildings, no line of trees, no hill right where the moon is supposed to be. Think ocean, big lake, open field, or a parking garage rooftop with a good view of the sky. Direction-wise, for most mid-latitude viewers in the north, the moon will be hanging somewhere between the southeast and the southwest during the key phases of the eclipse. If you're in the eastern US, think more toward the southeast as the eclipse starts and drifting south as it deepens. In the central and western US or southern Europe, it may be closer to due south or even sliding toward the southwest by maximum time. The practical takeaway is simple. Scout a spot with a clean SESW window and you're in business. There's also a really clear ease gradient with latitude. The farther south you are in the northern hemisphere, the higher and easier the moon will be to see. Someone in Southern California, Texas, or the Mediterranean might have the eclipsed moon a comfortable 30 or 40 degrees up, nicely above the murk. Meanwhile, if you're in Scotland or Scandinavia, the moon could be hugging the horizon, dimmer and hazier, fighting through more atmosphere. It is not impossible, but it's more of a challenge, especially for sharp photos. From my own experience shooting from the Boston area, low eclipses feel like a race. I've had the moon slide into Earth's shadow while it was weaving between downtown buildings, which is really neat, but also stressful. You're watching the clock, the clouds, and the skyline all at once. On the other hand, friends in the western US might be enjoying this at a much more comfortable evening hour, with the moon already higher and the sky fully dark, while parts of Europe are dealing with very late night or even pre-dawn timing. Now, everything I've said so far has been for the north. Our friends in the southern hemisphere actually get a bit of an altitude and direction upgrade, and their moon will look tilted differently too. How does that change where they should look in the sky? And what does it mean for your camera settings if you're watching from the south or planning a remote setup there? If you're watching from the southern hemisphere, you're actually getting a bit of a cheat code for this eclipse. While a lot of people in the north are fighting a low, murky moon near the horizon, your moon will often be riding much higher in the sky during the main phases, which is really interesting for photography. A higher moon means you're usually looking through less of Earth's atmosphere, less gunk, less haze, less heat shimmer. That translates into sharper detail on the lunar surface and cleaner edges on the Earth's shadow. Instead of that yellowish wobbly moon you sometimes see just after moonrise, you can expect something more neutral and crisp, especially around maximum eclipse, weather permitting. Now, in terms of direction, you have to make sure you're looking in the right part of the sky. For most southern hemisphere locations, the eclipse will play out somewhere between the northeast and the northwest. So think of a big arc from NE through due north to NW, and that's your hunting ground. If you can find a spot with an open view along that NE-NW sweep, you're golden. That might be a beach with a clear ocean horizon, a hilltop outside the city, or a rooftop terrace where buildings aren't blocking your northern sky. The exact angle will shift with your longitude and the local time of maximum eclipse, so I'll include the link again to the interactive map on timeanddate.com. Pop in your city, and it will literally show you where in the sky to look and how high the moon will be, which is really neat. Let me give you a concrete example. If you're in Sydney, by the time you get close to maximum, the moon is likely to be comfortably up in the north, high enough that you're not shooting through that thick, dirty layer of atmosphere near the ground. In Cape Town, or near Sutherland, where the South African Astronomical Observatory is, it's a similar story. The moon climbs to a nice, workable altitude while the partial phases are happening. That makes it much easier to track with a tripod, or to just set down a small smart telescope like the Dwarf Mini, tap lunar tracking, and let it do the work. Now, there is one fun twist. From the southern hemisphere, the moon and the shadow are going to look flipped compared to what people in Europe or North America see. Yes, your moon is technically upside down. No, the eclipse is not broken. The physics is identical. The beauty is identical. And this is one of those quiet proofs that the Earth is not flat. The key thing is that all the planning tools and camera techniques I'm talking about work exactly the same whether you're north or south. You still check your times. You still frame your shot. You still adjust your exposure as the moon darkens. But what if you're in a bright city and the sky never gets truly dark? Does light pollution ruin a lunar eclipse? And can you still get good photos at all? That's what I'll tackle next. Now here's the good news for all my city people. The moon does not vanish just because your sky is bright. If you can see the moon on a normal night from your balcony, rooftop or parking lot, you will be able to see and photograph this eclipse in some form, weather permitting. A lunar eclipse is not like the Milky Way, where light pollution can completely erase it. The moon starts out incredibly bright, and even when it's 96.2% covered, it's still getting lit by sunlight bent through Earth's atmosphere, which is really interesting. So even in a big city, the eclipse will be visible. The main thing that changes is how dramatic the colors and the surrounding sky look. Let me paint the extreme example. Imagine you're standing in Times Square in New York, or in the middle of Shibuya Crossing in Tokyo, screens blasting, streetlights everywhere, and you look up. You will still see the eclipsed moon hanging over all that chaos. It is not going to be pitch black and gone, but the contrast is tougher. The bright lit part will stand out, but the dim, shadowed part is more subtle, and your eyes have to work a bit harder. Under heavy light pollution, here's what you should expect. The sunlit crescent of the moon is going to be obvious and sharp. The part inside Earth's shadow may look more grey-brown than that deep, coppery red you see in dark sky photos. Those extra stars that pop out around the eclipsed moon in rural locations. In the city, most of those are simply washed out by the glow, so your view is more moon on a bright background than moon floating in a star field. Now, why does it get red at all? During the deepest phase, the only sunlight reaching the moon has passed through a long sideways slice of Earth's atmosphere. Shorter blue light gets scattered out, just like daytime sky blue, while the longer red and orange wavelengths keep going. That reddish light is bent or refracted into Earth's shadow and onto the lunar surface. So the moon is literally lit by a ring of all the world's sunrises and sunsets at the same time, which is really neat. For photographers, this is where location really matters. In the city, you have to make sure you expose a little longer for the shadowed side, and you may need to nudge white balance warmer and add contrast in post to pull out those red tones. In darker skies, the color looks more saturated straight out of camera, and you can frame the moon with stars or a silhouette foreground. In the next section, I'll show you why. If you can drive even an hour to a darker spot with a clear horizon, it can be emotionally and photographically worth it. Now, this is where dark skies turn a "hey, cool eclipse" into "wait, am I in a planetarium right now?" When you stay in the city, the moon is basically on a blank gray stage. As it goes into Earth's shadow, the sky around it doesn't really change. The glow from streetlights just wipes everything out. You see the eclipse, but you don't see the sky. From a dark site, it's the opposite. As the moon dims, the sky starts to fill in. First you notice a few bright stars near the moon, then more. Then suddenly there's an entire star field wrapped around this fading disk, which is really interesting because you realize how many stars are always there, just hidden by our own lights. It is not just a moon photo, but a sky photo. My most unforgettable eclipse night was the March 14th, 2025 total lunar eclipse, out in a Bortle 3 zone. Bortle 3 just means a pretty dark rural sky. The Milky Way is visible as a soft band, and the nearest city glow is just a faint dome on one horizon. I drove out, set up next to a quiet field, and the first half hour felt almost like a regular full moon session. Then the shadow started to bite in. The bright full moon slowly faded, step by step, until it turned into this deep copper disk hanging over the north side of the field. As it darkened, the constellations around it came alive. You could trace Orion, see the Pleiades, and the Milky Way started to whisper across the sky. The landscape dropped into this surreal, dim, twilight-like glow. Colors were muted, but shapes were still visible, which is really neat because your brain knows it's night, but your eyes think it's some kind of alien sunset. What I remember most wasn't just the view, it was the feeling. The air was still. People in the distance stopped talking. You could almost hear the sky. The stars brightened, the red moon inched along, and that slow motion of Earth's shadow sliding across our own satellite just etched itself into my memory. No filter, no time-lapse trick, just the universe doing its thing, weather permitting. Photographically, those conditions are a gift. With longer exposures, you start to reveal faint background stars around the red moon and even subtle greenish air glow in the sky. The final images look like they belong in a dome theater instead of a backyard. That's why, if you can, you have to make sure you at least consider a short drive to a darker spot with a clear horizon. Now, I know not everyone can escape the city tonight, and that's okay. In the rest of this video, I'll show you exactly how to make the most of whatever sky you have. And in the next section, I'm finally going to break down the exact gear checklist and the camera settings I use for every single phase of the eclipse. Now let's finally talk about the gear you actually need tonight, because this is where a lot of people get scared off for no good reason. You do not need a giant observatory or a fancy telescope to photograph this eclipse. You can absolutely take part with whatever you already have, and I'm going to break it into 3 simple tiers so you can see exactly where you fit. Tier 1 is smartphone only. If that's you, you're still in the game. The 2 things you have to make sure you have are a basic tripod and a phone clamp. Nothing crazy, just something sturdy enough that the phone doesn't wobble every time a truck goes by. That alone turns shaky blobs into sharp moon photos, which is really neat. Next, grab a manual camera app that lets you control ISO, shutter speed, and focus. I'll include the link to a couple of good ones in the description. Lock focus on the moon, keep ISO low, and use the timer so you're not jabbing the screen mid-exposure. And if your phone has a 2x, 3x, or even 5x telephoto camera, use that. You won't fill the frame, but you will get a clearly recognizable eclipsed moon. Tier 2 is an interchangeable lens camera, DSLR or mirrorless. Here the ideal setup is a body you're comfortable with, a telephoto somewhere in the 200 to 400 mm range, and a solid tripod. Around 300 mm is kind of the sweet spot for detailed moon shots, which is really interesting because it's still very portable. If you only have a 70-200, that's fine too. Zoom to 200, plan to crop later, or include some foreground like trees, buildings, or a snowy north-facing ridge along your horizon for context. If your camera has an interval shooting mode, or you own a cheap intervalometer, bring it. That will let you automate a time-lapse of the moon sliding into Earth's shadow without you touching the camera every 2 minutes. Now pattern interrupt for the gear nerds. What if you do want the easy button? That's where tracking mounts and smart telescopes come in. A compact smart scope like the Dwarf Mini can automatically track the moon across the sky, keep it centered, and even stack multiple short exposures to reduce noise. You control it from an app, so you're not out in the cold poking tiny buttons, and it makes longer focal lengths much more beginner-friendly. Whichever tier you're in, don't forget the small stuff. Extra batteries, it will be colder than you think. Extra memory cards, a remote shutter or at least a 2-second timer to avoid vibrations, and a headlamp with a red light so you can see your gear without nuking your night vision. And dress warmly. This eclipse takes time, and the moon does not care if your toes are frozen. In the next section, I'm going to give you exact starting settings for phones, cameras and smartscopes, and how to change them as the moon gets darker. So get your gear laid out now before the first bite of Earth's shadow shows up. Now let's actually dial in the numbers, so you're not guessing while the eclipse is racing across the sky. I want you watching the moon and enjoying the view, not stuck in the menu maze wondering why everything looks like a glowing ping pong ball. We start with the bright, uneclipsed moon. Remember, this is just sunlit rock, so you treat it like a daytime subject, not a night scene, which is really interesting because it's hanging in a dark sky. For a DSLR or mirrorless camera, a great baseline is ISO 100, aperture around f8, and shutter between 1/125 and 1/250 of a second. That will usually give you a detailed moon that isn't blown out. If your shots look like a white disk with no craters, you have to make sure you shorten the shutter a bit more or drop ISO. As the partial phase begins and Earth's shadow starts taking a bite, the overall moon gets dimmer, but that remaining bright crescent can still clip easily. So here I'll have you slowly stretch the exposure. Keep your aperture around f8, bump ISO to 200 or 400, and slow the shutter to about 160 to 130 of a second. Watch your histogram. You want the highlights for that bright edge just shy of the right side, not smashed against it. If you're north or south of me, the crescent might be on a different side of the moon, but the same idea applies. Deep partial and near totality is where people really struggle, because the eclipsed part can be thousands of times dimmer than the full moon. Now you open the lens if you can. Go to f4. Push ISO to around 800 to 1600, and your shutter will slow way down into the half-second to 1-second range. Longer than about a second, and the moon's motion starts to smear detail since it moves about its own diameter in roughly 2 minutes. If you're on a tracking mount or a smart telescope like the Dwarf Mini, you can go a bit longer, which is really neat for pulling out that red color. Phone users, you're not left out. In your manual or pro mode for the bright phases, drag the exposure slider down so the moon looks gray with visible craters, not a white blob. Lock focus on the moon. Keep ISO as low as the app allows and use the shortest exposure you can. Then, as the eclipse deepens, gradually raise ISO and let the phone lengthen the exposure. Take lots of frames. Stacking them later in free software can reduce noise and bring out the subtle orange and red tones. For color, set white balance to daylight or around 5000 to 5500 Kelvin so the look stays consistent over time, weather permitting. Shoot raw if your camera or phone allows it, so you can really dig into those reds later, and consider bracketing exposures during the trickiest partial phases. In the next section, I'm going to tackle the #1 eclipse photo killer, bad focus and blurry moons, and I'll show you exactly how to lock in sharp focus before the shadow show really gets going. Now, let's fix the thing that ruins more eclipse photos than any bad setting. Soft, mushy focus. You can have perfect ISO, perfect shutter speed, perfect timing, and still end up with a fuzzy grey potato where the moon should be. We are not doing fuzzy potatoes tonight. The first thing to understand is why autofocus lets you down. During the bright full phase, your camera might lock on the moon just fine. But as the eclipse deepens and the moon gets up to thousands of times dimmer, many cameras start to hunt back and forth or grab focus on a cloud, or on a distant streetlight, or even on the edge of your frame, which is really interesting but not helpful. So for eclipse work, you have to make sure you're in control. Manual focus with live view, or whatever your camera calls its on-screen preview. Here's the step-by-step method I use. Point the camera at the moon, turn on live view, and use the zoom in button on the LCD to go all the way in, usually around 10x. Don't worry, you're not changing your actual photo, you're just magnifying the preview. Now switch the lens to manual focus. Slowly twist the focus ring and watch the moon's edge. You want to see those craters and the limb snap from soft to crisp. If your camera has focus peaking, turn it on so the sharp areas glow with little colored edges, which is really neat for night work. Once you nail it, don't touch it. Seriously. Take a small piece of gaffer tape and gently tape the focus ring in place, or mark the spot with a tiny line so you can come back if it gets bumped. Recheck focus every so often, especially if the temperature drops and your lens cools. Glass can shift just enough to soften things over time. If you're using a smartphone, you're not left out at all. Aim at the moon, tap and hold on it to lock focus and exposure, and look for an AF/AE lock indicator. In a pro or manual camera app, drag the focus leader all the way to the little mountain or infinity icon, then fine-tune until the moon's edge looks as clean as possible. Tripod, lock, then hands off. And just like with a big camera, glance at your shots every few minutes. It's easy to brush the lens or the screen and move focus without noticing. Now, once focus is sharp, don't only shoot giant close-ups. Try putting the eclipsed moon low over a clear horizon with a tree line, or a city skyline, or even a telescope silhouette if you're in the north or the south and want that upside-down moon joke. Apps like Photopills and Stellarium can show you exactly where the moon will rise and how high it will be at maximum. I'll include the link to those in the description so you can plan a foreground that tells a story instead of just recording a circle. Even with perfect focus, though, real life is messy. Clouds drift in. Tripods vibrate when people walk by. Exposures go off the rails as the moon fades. So in the next section, I'm going to rapid fire through the biggest eclipse problems and the backup plans that save your night, because I want you going into this feeling prepared, not crossing your fingers and hoping the sky behaves. So let's start with the #1 eclipse boss fight: clouds. Even with perfect focus, if the sky is socked in, you're not going to see much. Before you pack up, check a satellite or cloud map for your region. I'll include the link I like in the description. You're looking for thinner patches or breaks that might drift over you around your local maximum time. Now, if it looks marginal, have a plan B that's maybe 20-40 minutes away in a different direction. Sometimes just driving a little north or south gets you under a gap, which is really interesting when you compare photos later. And if you end up with a partly clouded eclipse, don't give up. Those moments where the moon peeks through thin cloud can be incredibly dramatic, with this moody glow and soft halo that you just cannot fake in Photoshop. Next problem: vibration. The eclipsed moon is much dimmer, so your shutter speeds get longer, and suddenly every tiny bump matters. You have to make sure your tripod is actually solid, legs fully locked, nothing wobbling, not perched on a bouncy wooden deck where people are walking around. If your lens or body has image stabilization, turn it off when you're on a tripod. Otherwise, it can actually introduce blur while it hunts for motion that isn't there. Use a 2-second timer or a remote release so you're not poking the camera right as the exposure starts. If it's windy, stand upwind and use your body as a shield, or hang a small bag from the tripod to add weight. Try this test before the eclipse. Do a 1-second exposure of the moon and gently tap a tripod leg. You'll see how shockingly easy it is to smear the details. Exposure problems are the next big one. The moon goes from bright to about 10,000 times dimmer near maximum, so your settings cannot stay the same. Keep checking the LCD and, if your camera has it, the histogram every few minutes. If the bright part of the moon is slammed against the right edge, shorten the shutter or drop ISO. If it looks like a dull grey smudge, don't be afraid to crank ISO and lengthen the exposure aggressively. During the deepest phase, bracket your shots. For example, take one at 1 second, one at 2, one at 4. One of those will almost always be usable, which is really neat when you get home and compare. Now, what if you only have a phone and no tripod? You can still play. Brace your elbows against a wall or railing, lean your back into something solid, and use burst mode to fire a quick series. Short video clips work too. Later you can scrub through and grab the sharpest frame. And honestly, if you spend more time just watching the eclipse with your own eyes and only snag 1 or 2 decent photos, that is still a win. Speaking of making things easier, let's talk about that Dwarf Mini giveaway I teased earlier. The Dwarf Mini is a little smart telescope that can automatically track the moon, stack images, and basically handle a lot of the fiddly stuff for you. You set it down, connect with your phone, tap on the moon, and it keeps it centered while it grabs a whole sequence of shots. For future eclipses or just casual moon nights, it's kind of the easy button for a lot of people, weather permitting. To enter, you have to make sure you're subscribed to the channel, like this video, and then drop a comment telling me roughly where you're watching from and what gear you're using tonight, even if it's just my eyes and a lawn chair. I'll pick a winner after the eclipse window closes. I'll include the link to the full rules below so everything is nice and clear. In the next section, I'm going to zoom back out and give you a rapid-fire checklist. Timing, gear, settings, and a few last-minute reminders before you step outside and look up, so you can enjoy the view without wondering what you forgot. So let's zoom out and do a last-minute run-through before you grab your coat and head outside, because tonight really is your one shot at this particular alignment of the Earth, Moon, and Sun. Think of this as your pre-launch checklist, so you're not fumbling with menus while the shadow is already halfway across the moon. First, planning. You have to make sure your times are right. Go back to the eclipse map page on time and date. I'll include the link below. Double-check your local start, maximum, and end times, and look at the moon altitude at those moments. If you're in the north, you want a clear view from the southeast over to the southwest. If you're in the south, flip that. Northeast over to northwest. Pick a spot where the horizon is as clear as you can manage and where you don't have car headlights or a street lamp blasting straight into your eyes, which is really interesting because even though light pollution doesn't stop the eclipse, it can make your eyes work harder. Now, photography basics. For the bright, uneclipsed moon, start around ISO 100 to 200, f5.6 to f8 if you can, and a shutter in the ballpark of 1/250 to 1/500 of a second. As the Earth's shadow slides on and the moon gets dimmer, you'll gradually slow that shutter. 1/125, 160, 115, and eventually up into whole seconds near maximum if your skies are clear. Try to keep ISO as low as your tripod allows. Shoot RAW if your camera or app supports it, which is really neat because it gives you much more flexibility later. During the trickiest phases when part of the moon is bright and part is dark, use exposure bracketing so you get one safe bright frame, one darker, and one in the middle. Focus is where most eclipse photos die. Use live view on the back of the camera, zoom in digitally on the lunar edge, and very slowly turn the focus ring until the craters snap into sharp relief. Then don't touch it. On a phone, tap and hold on the moon to lock focus and exposure, then gently nudge the exposure slider down so you keep detail. If your moon looks like a glowing ping pong ball, it's overexposed. If it's a muddy gray blob, it's out of focus. Quick mental checklist before you walk out the door. Batteries charged and in the camera. Spare batteries in your pocket. Memory cards formatted with plenty of space. Tripod and remote or intervalometer packed. Warm clothes, hat, gloves, and a headlamp with a red mode if you have one. Maybe a thermos of something hot, because the universe does not care if you get chilly. Aim to arrive 20 to 30 minutes early so you can set up, test focus, and grab a few practice shots before anything dramatic is visible. And remember what you're about to see. You're literally watching Earth's shadow sweep across the moon in real time. That shadow line is the curve of our planet, which is one of the oldest, simplest proofs that the Earth is a globe, not a dinner plate. Up to billions of people across the world will be able to see some part of this eclipse, weather permitting, and you're one of them. Even if your photos are not perfect, just standing under the sky and watching our world move is absolutely worth stepping outside for. So here's what I'd love you to do. After the eclipse, come back and tell me in the comments where you watched from, what gear you used, and what went right or wrong with your shots. Post your favorite image or even your funniest fail. To enter the Dwarf Mini giveaway, make sure you're subscribed, leave that comment with your location and setup, and include the phrase I mentioned earlier so I can actually find your entry. I'll include the link to the full rules down below so everything is nice and clear and above board. If this helped you get ready, hit subscribe so you don't miss the next eclipse and the next round of night sky guides. The moon will keep lining up with our shadow. The stars will keep wheeling overhead. And I'd love to be out there with you again, walking you through how to see it and how to photograph it and how to keep pushing your images a little bit further every single time.